Assalamu alaikum. This is Ansari Yasmin teaching science in Anjuman Islam Abdul Azim Khatkate English Secondary School. Students, last video, I had explained you how to form the images by using convex lens. We had also seen that convex lens is also called the converging lens. Now today in this video I am going to explain you how to form the image or how the image will form if we will use the concave lens. And concave lens, you need to remember this concave lens. Here today we are going to discuss on concave lens, and concave lens is also called diverging lens because it diverges the light rays, and that is why it is called diverging lens. So let's start. First I'll explain you how to draw the concave lens, okay, how to locate its center of curvature, how to locate its focus, and after that I will explain you how to form the image when the object is kept at different position. So before starting, before drawing the concave lens, first we will draw a straight line which would be our principal axis. So here I am drawing a straight line. This would be my principal axis. Okay, so I'll use compass. Here I have a compass. I'm going to keep this pointer on this line and I'll draw an arc. Okay. So in this way we have to draw this arc, and the point where you have kept the pointer, this point you have to note it down. Okay, this would be your center of curvature. So here this I am writing it as 2F2. Okay, now without disturbing the distance in the compass, now I'll keep the pointer on this side and I'll draw another arc. Okay, so we need to remember the point also where we had kept the pointer. I'll mark this point. This would be our another center of curvature, which would be denoted by 2F1. Okay, now join these lenses, join these two arcs. Here I have joined them. Okay, so this would be our concave lens. Here there would be optical center. Okay, now what we need to do, I will take a distance from optical center, to the center of curvature. So here I have taken a distance and it is showing 4.8. so we need to take half of this distance of 4.8. So it would be 2.4. So I will mark point on 2.4 here, and on this side also we will locate a point at 2.4. So this would be my another point. These 2 points would be our focus. Okay, this would be F2 and this would be F1. So this is how we can draw the concave lens. This would be the principal axis 2F1 and 2F2, these are two center of curvatures. F1 and F2 are the focus, and this O is the optical center, and this is our concave lens, which is also called the diverging lens, as the concave lens diverges the light rays. So this was the first step where I have explained you how to draw the concave lens. Now in the next one we will see how the concave lens will form the image if I will keep the object at infinite distance. Okay, if I'll keep the object at infinite distance. So if object is kept at infinite distance, the light rays coming from the object would be parallel to the principal axis. See, the object is kept at infinite distance, so this infinite distance I cannot show you on the paper. So we have to imagine that the light rays coming from the object kept at an infinite distance is coming parallel to the principal axis. So I will draw here the light rays coming from the object kept at an infinite distance. It is coming parallel to the principal axis, and as I have told you, the concave lens is a diverging lens. So this incident ray, after falling on the lens, it will diverge. It will diverge in such a way that it should look like it is coming from the focus. It will not diverge anyhow. The light ray will diverge in such a way that it should look like it should be coming from the focus. Okay, so this is the first diverging ray. Suppose if another ray is coming parallel to the principal axis from that object which is kept at an infinite distance. This is the another light ray coming from the object which is kept at an infinite distance. So again this will diverge, but it will diverge in such a way that it should look like coming from the focus. I cannot diverge it anyhow. It should look like coming from the focus. So I will diverge it from here. Okay. Suppose if the light ray coming from that object which is kept at an infinite distance below the principal axis, from here, which is parallel to the principal axis, this light ray will also diverge. But how will it diverge? It will not diverge anyhow. It will diverge in such a way that it will look like coming from the focus. So now I will diverge it here in this way. Suppose if I am taking one more light ray coming parallel to the principal axis from the object kept at an infinite distance, this light ray will also diverge, but it will diverge in a way that it should be looking like coming from the focus. So it will diverge in this way. This would be the way of divergence of this light ray. Okay. So here if you will see, these light rays are diverging. So if these light rays are diverging, if they are not intersecting, so they will not form the image in front of the lens, this side of the lens. So what we will do to form the image, we will extend these diverging rays behind the lens. Okay, so what I will do, I will extend it behind the lens. Okay, this light ray, then this light ray is also diverging, but it is looking like coming from the focus. This light ray, then again this light ray, and this light ray will also diverge, but it would be looking like coming from the focus. So all these light rays will be meeting at focus 1. Okay, so the image will form on the same side of the lens where the object is kept. See, the object is kept on the left side of the lens and image is also forming on the left side of the lens. On the same side of the lens, object and image is forming. Now we need to describe this image also. So first of all, we need to describe the nature of image. We have to write. So in nature of image, first we will write, because the image is forming on the same side where the object is kept, it would be virtual image. It would be virtual image. In the last video only I have explained you, if the object is on one side and image is forming on the other side, then it would be real image. But if both are on the same side, then it would be virtual image. So here the image is virtual, and as you can see, very small point image is forming. So you can write here point image is forming. So we cannot say it would be erect or inverted. Point image will form. Okay, or you need to remember this. If we need to describe is erect or inverted, I had given you in the last video keyword that if the image is real, then it would be inverted, but if the image is virtual, it would be erect. So you can write here it would be erect image. Okay, so it would be virtual and erect image. Now the last thing, what would be the size of image? As you can see, a very small point image is forming. So here you can write point image is forming, and position of object, when we have to write position of image, position of image where the image is forming. So you need to write at F1. Image is forming at F1. You need to write position of object also. In the starting only I have explained you where I have kept the object. I cannot show you the object on the paper because the object is kept at an infinite distance. I can only show you the light rays coming from that object. So object is kept at infinity. So here I will write at infinity. So in this way you have to draw the ray diagram. You need to write position of object, then you have to draw the ray diagram, then you need to write nature of image, size of image, and position of image. So complete ray diagram in this way you have to make. Okay, this was the first condition, when the object was kept at an infinite distance. Now again we are using concave lens. Okay, we are using the same lens, but now I am keeping see, in concave, like in convex lens there were 6 cases. The first case was where I kept the object at an infinite. Now I am keeping the object anywhere between optical center or F1, or between F1 and 2F1, or beyond 2F1. I will keep object anywhere, but it will form the image always between the optical center and F2. Let's see how. So here I am making the object, and now I am keeping the object between 2F1 and F1. Here I am keeping the object. This is my object, and I have to make its image. It will form the image between optical center and F1 only. Let's see how. Okay, we already know the 3 rules. So I am applying here the first rule. If an incident ray is parallel to the principal axis. So here I am drawing a light ray coming from the object which is parallel to the principal axis. This is the light ray coming from the object parallel to the principal axis. Okay, light ray coming parallel to the principal axis. Then because it is a concave lens, this will get diverged. Okay, this will get diverged, but it will diverge in such a way that it would be looking coming from focus. Okay, so how will it look like? It will diverge in such a way that it would be, it seems to be coming from the focus. See. Okay, so the first rule I have applied. Now the second rule which we will apply here, third rule is my favorite rule, so I will apply that rule instead of second rule. So second rule says, if incident ray falls on optical center, then no refraction takes place and without bending light rays passes through the lens without bending. Okay, so this would be the another refracted, this would be another ray. Now these two rays are not meeting or not intersecting. So what I will do, I will extend this refracted ray behind the lens, as it would be coming from the focus. Okay, now here if you will see, this ray and this ray are intersecting at this point. Okay, are intersecting at this point. So at this point your image will form. Your image will form here. This would be your image. Okay, now let's describe this image. First we will write position of object. Position of object. I have kept an object between F1 and 2F1. So I will write here between F1 and 2F1. Now position of image. In position of image, as you can see, this is your image which is forming between F1 and O. So you can write between optical center, and focus, or you can write F1. Okay, now nature of image. Because object and image both are on the same side of the lens, so nature would be virtual. It is virtual image. And as you can see, object is above the principal axis, image is also above the principal axis, so it would be erect image, virtual and erect image. And last, size of image. By looking only you can tell that image is smaller than object, so we can write diminished, or image is diminished. Now this case is for this ray diagram which I have drawn. This would be applicable for the object kept at a different position. If you keep the object beyond 2F1, or if you keep the object between 2F1 and F1, or if you keep the object at 2F1, or if you keep the object at F1, your image will form always between optical center and at F1, and it would be erect only and it would be diminished only. Okay, and that is why there is only two cases for concave lens. One case where the object is kept at an infinite distance, the image was forming at the focus, it was a very small image, point image was forming, and when the object is kept anywhere between optical center and infinite distance, your image will always form between optical center and f1, and it would be always erect, virtual and diminished image. Thank you.